name is Mrs. Jenkins. I'm here to give you some help in looking at solving systems of equations using elimination. Now, when you have a system of equations, there's three different methods that could be used to solve a system of equations. And I just want you to understand that there are three options here. The first one is graphing, the second one, substitution, and the third one, elimination. All three methods can be used, but we're going to focus on this third method, the method of elimination. Now, there's certain steps that we want to follow when we're using the method of elimination. First of all, if the equations cannot be eliminated, and I'll explain what I mean by that in an example in just a minute. But if they can't be, then we're going to multiply one or both of the equations by a constant value. After we do that, we're going to add and subtract the two equations together. Our reason for doing that is to eliminate a variable. You see, we want to end up with a 0x, or we want to end up with a 0y. When we add our two equations together, we want to get either a 0x or a 0y, because basically that just eliminates that variable. One or the other needs to occur. Once we add those two equations together, then we'll solve for the remaining variable. We can then substitute that known value into one of our original equations, and we'll solve for the second variable. Here's our first example. As you take a look at this example, in this problem, we can go ahead and add right away. Now, you might not recognize that at first, but let me show you what I mean. You see, if we consider the 3x and the 2x, and we think about adding that together, that would give us 5x. Doesn't eliminate that x. If we subtracted here, we would get 1x. Once again, does not eliminate. However, if you look at our y variables, we have a positive 1y and a negative 1y. And when we add our y's together here, we're going to get 0y. So we can skip the first step here. We don't have to multiply. This equation is ready to eliminate already. And it's good if you can recognize that. That happens whenever your coefficients of a variable are the same, or as they are in this case, they're opposites. So let's just go ahead and add right away. 3x plus 2x is 5x. When we add 1y and negative 1y, it is eliminated. Now if we go ahead and add 12 plus 3, we get 15. 5x equals 15. If we divide both sides of that equation by 5, we get our first part of our answer, x is equal to 3. Now we know what one of our variables is. We can go ahead and substitute that into one of our original equations. I'm going to go ahead and write the first equation, 3x plus y equals 12. It doesn't matter which equation you choose to use. I'll just pick the first one simply because it's first. Now we know that x is 3 here, so I'm going to go ahead and substitute in that value of 3 for x. So we have 3 times 3 plus y equals 12. 3 times 3 is 9. We want to solve for y, so let's subtract 9 from both sides of our equation, and we find that y is equal to 3. So our answer here is the ordered pair where x is 3 and y is 3. Our answer, 3, 3. Now this one was ready for elimination. Let's take a look at a second example where it's not ready for elimination. You see, if we add or subtract here, x will not be eliminated, neither will y. So we have to take a look at our variables and select to get rid of or eliminate either the x or the y. Let me just give you a hint here. If you've got a plus and a minus, that's good. I would encourage you to kind of go with that. So let's go ahead and try to eliminate the y. But there's no way we can eliminate them as they are. We're going to have to multiply this first equation by some number. We're also going to have to multiply the second equation by a different number, so that the y's will have similar values. In this case, they'll be opposites. Think about that for a minute. If you understood all that I just said, what number do we need to multiply this first equation by? What number do we need to multiply this second equation by? So that when we add, the y's will be eliminated. We'll get 0y. Consider that, and when you think you know, click continue at the bottom of the screen to check back in. We're going to want to multiply our first equation here by 3. The thing that we want to focus on is why 3? Well, because that's going to give us a plus 6y. And if I multiply the second equation by 2, that's going to give me a minus 6y. That's what tells me what numbers to pick there. What will make me have a positive 6 and a negative 6? Kind of have to work backwards there and think what you want to get. So what do you have to multiply by? Now, we do have to multiply the entire equation, the first one by 3. 3 times 3x will give us 9x plus 6y, and then 3 times 1 gives us 3. Don't forget to multiply the entire equation, first there by 3. The second equation must all be multiplied by 2, giving us 4x minus 6y equals negative 16. Now we're ready to add. 9x plus 4x is 13x. When we add our y's here, positive 6y and negative 6y, we get 0y. It is eliminated. 3 plus negative 16 is negative 13. If we divide both sides here by 13, we're going to be able to solve for our variable x. We get that x is equal to negative 1. So we know what one of our values is. We can substitute that into one of our original two equations. Once again, I'll just go ahead and pick the first one. 3x plus 2y is equal to 1. We know here that x has a value of negative 1, so we'll substitute that in, negative 1 for x. Now we want to solve for y. 3 times negative 1 is negative 3, plus 2y equals 1. Let's go ahead and add 3 to both sides of our equation, giving us that 2y is equal to 4. Now to solve for y, we need to divide both sides by 2, and we find our answer, y is equal to 2. Our final answer then is the ordered pair where x is negative 1 and y is 2. That's a look at a couple of examples of solving systems of equations using the method of elimination. Work well.